Hi. Nice to be able to update you a little bit on our group work. Today I'm joined by Brandon. Unfortunately, we have not Brad with us, who's from the Data Center Facilities Group, and his very active role in our group because he's also building modular data centers.
So we've given this presentation a bit before. There's now quite a lengthy history with modular data centers and what they comprise of, and if anything, it's really the process of turning a piece of infrastructure into a product than any particular shape or form of it. It can go inside of a facility, it can be its own facility. So it's really more about the process of the thing you're making than it looking a certain way, if you will, as far as the background of it. We can talk a little bit more about what some of the market drivers are that continue to push this, what things are as far as the existing level of definition and specification, what our work stream is trying to do in terms of developing additional publications, what the status of some of those are, and then further into hoping that we can get more total participation in that work group. So these are very familiar industry drivers. There's a lot of things about disaggregated, decentralized compute that's really pushing standardization, but just like the presentation that we saw beforehand, there's a lot of market drivers for automation because just the total amount of compute deficit that we have, the total amount of capacity we have to get online, we can't do this without standardization. We just can't achieve the throughput. And when you're doing nothing more than on-site localized construction, you're not getting that standardization. So we're building suboptimally, we're building with less efficiency, higher cost, higher material waste. And all these different industries, all these market drivers that are pushing for compute, these are just the terms of art at the moment, but in 5 years' time it'll be a different set of reasons. But AI and machine learning is really driving a need for a huge burst in additional compute capacity at the hyperscale level, but 5G, remote work, that sort of decentralized caching of data is going to drive not needing a few hundred sites a year, but thousands and thousands of sites, and you can't do that without standardization. If you already have a standardized product or a standardized solution, you might as well build it as a productized solution as well, because then you can get the additional benefits of quality, speed, consistency, and reduced risk. So again, just talking about the headlines that we're all seeing, there's a lot of convergence of a lot of different, not singular industry threads. This is something that Karl and I were speaking about here recently. You already had the edge space. You had the telecom driver that was trying to push for, decentralized, all these facilities, basis cell towers, so on and so forth. That's definitely still happening. And then you've got automation in vehicles and AI and machine learning. Again, that's a whole different market driver for it. Interestingly enough, the things that are happening with cryptocurrency mining, which is effectively just another form of decentralized compute, is helping mature some of the form factor and in design conditions for productized infrastructure and modular data centers. So these are all coming from different market motivations, but they result in the same outcome, which is a productized piece of infrastructure. And then again, just echoing the remarks from the previous presentation, when you're actually in an operational facility, this is of course going to push in the direction of then automating processes. But the actual building of the infrastructure suffers from the same sorts of issues where you've got chronic labor shortages. This is a long-term trend and will continue. We've got supply chain shortages. We still haven't gotten to normalized markets. And then just increased costs. Now, when you build things as off-site productized things, you substitute for other costs. So it's not necessarily always the case that you're building for less, but you can still have the net gain of reductions in risk and predictable outcomes. There's a lot to be said about predictable outcomes, especially in a situation where we've got such volatility in our supply chains. So there are different examples. Folks have come into and out of this market at different times. They've left then artifacts of what some of the specifications are for those. Not all of those, a lot of those are proprietary documents, but in the spirit of open compute, what we're trying to do is take a lot of that body of knowledge, those different existing standards and usher them into more of an open standard that's more easily referenceable so that you can get more total market participants to be building these sort of productized solutions. So there are examples, but we want to get to a more uniform body of publications that are available. So Brett, who would have been here, so his organization and Schneider, they have been working closely together for a lot of years on a particular form factor, and one of them is this 90 kW design. So, you know, very grateful that you've got an organization with the reach and the engineering strength of Schneider, and then PCX, who's now a part of Hubble's team. This is a really positive thing. It creates sort of a virtuous cycle. We have a lot of other folks in the space, major equipment manufacturers, such as Vertiv, that are trying to help normalize market conditions. The more we can get to uniform standards that are more easily adopted by the next company, it, again, creates a virtuous cycle. Did you want to pick it up from here?
Yeah, thanks, Brendan. Happy to jump into that. So there have been specific designs already focusing on OCP standards. This is specifically designed for the ORV2 by a company called Swedish Modules, and just showing the efficiency in terms of space requirements that this can those are all existing, and those here are there to use and to look into. There's another specification, is the Tencent 130 specification, which was published a little bit before Brendan my time, and we're trying to reconnect with the existing the creators of that, reaching out to Tencent, seeing how we also can promote those localized solutions from a Chinese perspective.
It's a lot of different shapes and forms that you've seen just visually in a couple of these different examples. You've got the skidded application. You have something that's a full turnkey application that had, you know, out-of-house mechanical, and then an enclosure, and then this is just 2 modules. So as you can see, if you're trying to drive uniformity, you know, standardization, you've got all these real estate. So in a lot of the parts that Open Compute works with, you know, say at rack level, there are fewer degrees of freedom. And when you get up to these facility scale types of applications, you've got a lot of degrees of freedom. So it's kind of a stiff wind to work against if you're trying to really develop maybe what the guideline documents ought to be. Like, what would be the underlying, you know, the connective tissue between the last 3 images that we saw. That's the challenge that we've been trying to overcome, is figuring out what can you use as a guideline document for, you know, an open standard that could be adopted more widely.
And our latest addition to the specifications is also a liquid-cooled specification. Vadim from Thermocon, who we worked successfully with, is here in the room. If you have questions regarding this, please reach out. And we were able to show that on this very popular frame, we were able to increase the power by over 3-fold. Also using the Modular Datacenter to highlight efficient technologies, for example, as the chiller you see is a very special adiabatic solution that uses 90% less water than a conventional water tower. It's a quite ingenious solution from a company called Fritschel, where we always trying to reach out to the industry and see if we have solutions to promote. We are preparing other solutions. This is something that we worked with the rear door cooling community. This is a talk just after this. Please feel free to run after me when I'm heading out towards across the expo hall to another location. And we were able to show that with the advancements in the Open Rack V3 with integrated automatic manifolds and rear door cooling, we were further increase the density of this module by another 3-fold. And there's quite exciting details that we have there, which will come up in a white paper.
Yeah, in terms of like the form and fit, when we think about like the rack level open standards, a lot of things that we focus on is the form and fit aspect of the problem. But with the modular data center, you know, and it being again, with many, many more degrees of freedom. The actual implemented technologies such as liquid cooling, as a as part of that sort of guiding standardization, it might be more the applied technologies that might be a more successful path for some of the publications that could be produced to drive standardization with modular data centers.
Yeah, we do have some further white papers that we are working on. One is the MDC white paper started with Rabe, just trying to give an introduction into modular data centers. There's another liquid cooling technology we highlight, which is, I'm not sure, I've not seen him in the room yet, but Zutacore is here, has a booth. We reach out to them, they're showing what they're doing. It's quite interesting technology, and the picture was shown on what we're working on. We do also continue to work on specs, really trying to follow the standardization process that Brandon mentioned, really trying to set an industry standard, and following OCP's new base product, base design product specification file. And this base specification really tries to narrow down what kind of cube formats you have, and we want to use that also to bring in a whole lot of other of the industry providers, the Vertivs, the Ritals, to have really everyone be participating in this base of standardization, so that they then can now and use this platform to highlight their technology, whether it's a UPS, a cooling technology, 19-inch, 21-inch rack provider. We really believe that the modular data center platform is ideal to make other solutions shine and show them in a complete environment. Another aspect that we would have loved to show already, this OCP, because of a legal rebranding to Iconic Modular Data Center, is only happening in the end of this year. But it's a really interesting concept that takes modularity to extreme, having a module for each rack and each component. Very interesting spec that we're happy to promote. The OCP is, for me, also spectacular because it provides design files. On the server level, those are very vast and very available. For the facilities, we have not seen them at all. Those have been a spec, but in conjunction with the base spec, we also want to start to create design files for existing specification, and starting off with the work we've done together with Vadim, we are in the final steps to release our first design file. Those will come in very easy to digest formats in step and free-cut design, and we want to continue that for our other specifications. Yeah, and with this together, we come to already the end of this of the update. There's a lot going on. We try to navigate on a modular level the AI storm of infrastructure. We're happy to invite you to look out for the specifications, join our mailing list, look into the wiki, and yeah, join the modular revolution.
So we could continue to use more breadth in terms of the perspectives that are involved. Right now we have a lot of, say, individual technologies or individual vendors that might provide a discrete component that might be suitable or being applied into a modular data center. We've got folks like Roxtech and other example technologies where it's one sort of discrete subcomponent in that bill of materials, but people who are dealing with the full scale of the problem, so design engineer firms, data center operators, other people who are building productized modular data center solutions. These are the perspectives that are going to think about and look at the problem comprehensively, and then it'll allow us to distribute more of the workload, get more throughput, and get things published so we can actually start to create some results. So we need more than just the individual technologies. We get a lot of interest and attention from those, but this is a facility scale problem, so we could really use people who think in that facility scale lens. So if you're out there, come help us out.
With this, we're thinking, yeah. Yeah, I'll have, yeah, please ask the questions to Brandon. I'll pack up and move to the next presentation. Sorry, but I would love to.
You guys have a tough job, and just listening and walking the floor here this last couple of days, and you see the breadth of different solutions. And what I guess the only comment I would make is you're coming in after the fact and trying to standardize for existing infrastructure. And one thing I did learn while I was here is that immersion cooling seems to be at the beginning, and it's just in the sort of development stage. And I didn't see any mention of immersion cooling, so instead of waiting for it to come out, can you not try to direct the development into a certain form factor that best allows you to standardize?
Okay, thank you. So everything liquid cooling it's interesting because we would look at it, and this is my own personal editorial, by the way, that immersion may be something of a transitional technology just because the amount of material that it uses for the cooling process it's less material efficient for that high value material than, say, direct on chip technologies. You know, and two-phase being similar between that versus single phase. So that's where we've been trying to your point, that's where we've been trying to think about from a space efficiency, because when you're building data centers as a product, air is expensive. So thinking about ways that are dense, that you know, maybe get you can reduce the number of components that you need. That's why there's been a lot of attraction and interest with direct-on-chip two-phase liquid cooling, because it's an extremely space-efficient component that's highly compatible with a productized data center. I don't know if I answered your question, if we're just talking about cooling technology, but in a general sense, yes, there is a need to keep paying attention to how can we steer that infrastructure design towards some of these emerging technologies. That's definitely a necessary part of the process, and that's why we need people who are constantly thinking about and working on the problem in that kind of comprehensive way, because again, with an infrastructure problem, there are a lot of degrees of freedom. So you can find yourself in this loop of boiling the ocean, which then delays you getting to publications, which means you're not adding that sort of incremental value add with sort of moving in the direction of more standardization. Again, I might have gone a little off script from your question there, but I hope there was some nugget in there. That's it? Okay. Thanks, Madhu.